Hey, welcome. Today, we're going to decode the secret language of the universe. We're talking about the system of measurement that physicists use to describe literally everything, from a tiny particle to a massive galaxy. This is the absolute foundation of physics.
But here's a really interesting question to kick things off. How can a physicist just look at a brand new, totally untested equation and know almost instantly if it has a shot at being right or if it's just complete nonsense? It almost sounds like a superpower, doesn't it? Well, by the end of this explainer, you'll know exactly how they pull it off.
All right, so here's our game plan. We're going to start with the real basics of how we measure the world. Then, we'll dive into the two main types of quantities and the universal language that scientists have to use. And after that, we'll get to the cool part, uncovering that secret code of dimensions that lets us fact-check any physics equation out there.
Okay, first things first, we have to get a handle on the absolute bedrock of physical science. So, what exactly is a physical quantity?
You know, it's actually beautiful in its simplicity. A physical quantity is just anything you can measure. That's it. It's always got two parts, a number that tells you how much and a unit that tells you of what. This is kind of the golden rule in physics. If you can't measure it and give it a number and a unit, you really can't build a science around it. We actually do this all the time, probably without even thinking about it. Like when we say a table is 5 meters long. 5 is the number, meters is the unit. Or if a bag of flour has a mass of 2 kilograms. 2 is the number, kilograms is the unit. Simple, right? But this is exactly where things start to get really interesting. See, this simple idea is where everything else comes from. Because it turns out not all quantities are created equal. They fall into two totally different categories. You have the basic building blocks, and then you have all the things we create with them. The best way to think about this is to imagine you're cooking. Seriously, on one hand, you've got your fundamental quantities. These are your raw basic ingredients, flour, water, salt. They're totally independent, and you can't break them down any further. But on the other hand, you have derived quantities. These are the recipes you make by combining those ingredients. Think bread or pasta, stuff you make by mixing the flour and water together.
And what's just wild is that physicists have figured out there are only 7 of these fundamental ingredients for the entire universe. That's it. Everything we can possibly measure, from the speed of a car to the pressure inside a star, is built from some combination of just these 7 things: length, mass, time, electric current, temperature, amount of substance, and luminous intensity.
Now, if you've got scientists all over the globe trying to cook from the same recipe book, they all need to agree on what a cup of flour actually means. And in physics, that means we need a standardized system of units. This is where the SI system, that's the International System of Units, comes into play.
This is how that universal language gets put into practice. Each one of those 7 fundamental quantities gets a standard SI unit. So length is measured in meters, mass in kilograms, time in seconds, and so on. This system makes sure that a physicist in Tokyo and an engineer in California are talking about the exact same thing when they take a measurement. It's absolutely crucial. Okay, so we've got our ingredients, the fundamental quantities, and we have our standard measurements, the SI units. Now we get to the really cool part, the secret code that's hidden inside every single measurement. And this is the concept of dimensions.
A dimension is just the exact recipe for any physical quantity. It shows you precisely which fundamental ingredients were used to make it and how. We usually represent these ingredients with symbols, like a capital L for length, M for mass, and T for time.
Let's use a classic example to make this clear. Force. We all kind of know what force feels like, but what's its fundamental recipe? Well, we know the formula for force is mass times acceleration. So to find its dimensional recipe, all we have to do is find the recipes for mass and for acceleration.
So here's how that recipe breaks down. Mass is one of those fundamental ingredients, right? So its dimension is just m, but acceleration is derived. Its dimension is length divided by time squared, or LT to the minus 2. When you multiply them together, you get the unique dimensional signature for force, mLT to the minus 2. That is its universal, unchangeable recipe.
So, why is this secret code so important? What's the big deal? Well, because it gives us that superpower we talked about at the very beginning. We can use dimensions as the ultimate fact checker for our physics equations.
Let's go right back to our initial mystery. Take this famous equation of motion. Final velocity, v, equals initial velocity, u, plus acceleration, a, times time, t.
Can we actually prove that this is a valid structure without doing a single experiment? The answer is yes, absolutely we can.
All right, let's break it down. First, we look at the left side of the equation. We just have velocity, v. The dimension of velocity is length divided by time, so that's Lt to the minus 1. Now for the right side. The first term, initial velocity u, well, it's also a velocity, so it has the exact same dimension, Lt to the minus 1. The second term is acceleration, which is Lt to the minus 2, multiplied by time, which is just t. When we combine those two, we also get Lt to the minus 1. They all match.
And this is the whole point, because every single term in that equation has the exact same dimension, Lt to the minus 1. The equation is dimensionally consistent. This is something called the principle of homogeneity. It's a fundamental check. You can't add a speed to a weight, right? It just doesn't make sense. The dimensions have to match up, and in this case, they do. Our equation is legit.
So let's just do a quick recap of what we figured out. All physical measurements in the entire universe are built from just 7 fundamental building blocks. Every single quantity, from speed to energy, has its own unique dimensional recipe. And, most powerfully, we can use these recipes as an incredible tool to check if our physics equations even make logical sense in the first place.
And that really brings us to a final thought. We've seen how dimensions act like a fact checker for physics, which is amazing. But that's just scratching the surface. This same tool can be used to figure out new relationships between quantities we didn't know existed. So the real question is, if this simple secret code can verify our equations, what other secrets of the universe is it just waiting to help us unlock?